Hello class, in this video I'll be showing you how to sketch the graph of a rational function. Let's begin. Sketch the graph of g of x is equal to 3 divided by x squared minus 2x minus 3. And I'm going to start by determining the domain of g of x. So I'm going to set the denominator equal to 0 and solve for x, because the solutions to this equation will give us the values of x that make g of x undefined. So x squared minus 2x minus 3 factors as x minus 3 times x plus 1, which means x is equal to 3 and x is equal to negative 1 are solutions to this equation. The domain is the set of all real numbers x such that x doesn't equal 3 and x doesn't equal negative 1. In interval notation, that would look like this. Part B. Find the coordinates of any removable discontinuities, if any exist. Since g of x is in lowest terms, there are no removable discontinuities. Part C. Find all the vertical intercepts or state none exist. To find the vertical intercepts, we need to evaluate g of 0, and that will equal 3 divided by 0 minus 0 minus 3, which is equal to negative 1. So the graph of g of x passes through the point 0, negative 1. Part D. Find all horizontal intercepts or state that none exist. To find the horizontal intercepts, we need to set the function equal to 0. And a rational function is equal to 0 when the numerator is equal to 0. So here we have 3 is equal to 0, which is clearly a false statement. Therefore, there are no horizontal intercepts. Part E. Find the equation or equations of all vertical asymptotes. Since g of x is in lowest terms, all the values of x that were excluded from the domain are the location of vertical asymptotes. Their equations are x is equal to 3 and x is equal to negative 1. And finally, part F. Find the equation of the horizontal or slant asymptote. The degree of the numerator is 0 and the degree of the denominator is 2. So we have m is greater than n, which means y is equal to 0 is the horizontal asymptote. Now we are ready to sketch the graph of g of x. So I've gone ahead and sketched both the vertical and horizontal asymptotes along with the vertical intercept. Now what I'm going to do is determine the behavior of the graph between the two asymptotes. To do that, I'm going to evaluate g of 2. g of 2 is also negative 1. Since there are no horizontal intercepts, the shape of the graph looks like this. To determine what the graph looks like to the left of the asymptote x is equal to negative 1, I will evaluate g of negative 2. g of negative 2 is 3/5. So we have negative 2, 3/5. So the graph of g of x will look like this. To determine what the shape of the graph looks like to the right of the vertical asymptote x is equal to 3, I will evaluate g of 4. g of 4 is also 3/5. Thus, the graph will look like this. And that is the graph of g of x. And we are done.